Okay, I was just about done with this slide. Anyhow, this is anthracite. This is the highest grade of coal. All right, so that's extremely desirable. Um, you basically get more energy from this. As far as uh, let's see if it talks about it. Most characteristic most characteristic feature of sedimentary rocks is blah, 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 this one right here. Um, so of all these, they certainly can have fossils. Um, Lithification, of course, is the turning of basically literally turning stuff into rock, like little sticks or leaves or biomaterial. Um, that certainly is true, and it does cement. But the biggest characteristic, the most important one, is that this sedimentary rock is layered, right? This layers of strata. All right, you'll see that here. There we go. All right. Let's see. Yeah. So before we get into metamorphic rock, let me go back to this because I mean it's so important to our society. We still rely on fossil fuels. So that this would be these chemical sedimentary rocks that produce coal. Uh, they could also so you can also produce um, uh, nature produces under certain conditions the you get a lot of pressure, and there has to be certain porous rocks around, and you get the pressure in the porous rocks, and the basically oil will be squeezed out of this. Um, and then under other conditions, you can have natural gas um, being produced as well. Um, so, for example, we're thinking about where we live in the Appalachian Mountains, West Virginia and into Kentucky and that area. There is tremendous deposits of this anthracite coal. I mean, there's some of the bituminous coal as well, but there's a lot of this, and it's still there. It's still, we're still actively taking it out of the ground. Um, in fact, I saw something one time um, that there is still. I mean, if we were to just completely, uh, continue to take this coal out of the ground, although there's obviously environmental issues about that, but there is at least enough coal there for the next 700 years. And that's even assuming that, we're to use more and more of it as time goes on. Um, all right. Of course, the biggest problem, and we'll talk more about this in future chapters, but I think I mean, it's not like it's a big mystery that the burning of coal, the burning of oil, the burning of natural gas, and coal and oil and natural gas, of course, collectively are called fossil fuels because it required dead things to make it, and stuff that's been dead for roughly 300 million years, right? So that's again what we'll talk about in future chapters. But this causes carbon dioxide to go up into our atmosphere, and in incredible abundance, like a lot more abundance than just what is naturally occurring. Like the fact that humans are burning coal and driving cars, which the oil is turned into gasoline, and of course we burn natural gas as well. and the byproducts of all that burning of fossil fuels is we increase the amount of carbon dioxide in the atmosphere, and over time it's substantially noticeable. We've greatly increased the amount of carbon dioxide, and so that's causing the overall Earth to be, because carbon dioxide traps heat. It's one of the gases that traps heat. It's causing the Earth to warm up, and we have to deal with the consequences of burning these fossil fuels. All right, so like I said, we'll return to that stuff. It is very important to our society today. Hopefully, in the future, we'll turn away from our incredible dependence on fossil fuels, but it is an absolute dependence on fossil fuels, the way we are today, the way things are today. All right, the last of the three types of rocks, right? Just to remind you, igneous, sedimentary, and then the last one is metamorphic, right? Igneous, of course, is when you have magma that is turned into rock, either inside of the Earth or right at the surface of the Earth, and then when it happens at the surface, that's lava. Usually, when it happens at the surface, that's for the most part, you're getting what's called basalt, and the granite comes from way under, really far underneath the Earth. That's when the magma turns into rock underneath the Earth. All right. So anyhow, and then of course we just talked about sedimentary rocks, right? Clastic and chemical. All right. So metamorphic rocks. So it turns out you can turn any of these igneous rocks, sedimentary rocks, or even metamorphic rocks that exist already as metamorphic rocks into metamorphic rocks. So here's what metamorphism is. It's when you recrystallize the rock. And you're doing that usually through some kind of mechanical deformation. So you're deforming the rock, and we'll learn there's a term called foliated. Not all the metamorphic rocks are foliated. Unfortunately, foliated is actually really easy to identify if you're just trying to identify rocks. All right, so this is what happens. You have. So let's say that there's some rocks and then there's some magma or this is deep inside the Earth. Some magma, gets close to those rocks, and so there's an increase in temperature, and of course if there's water present, that affects things as well, because you get chemical activity that's going on. Remember, this is deep inside of the Earth, where there could be let's say there's rocks already that had formed, like let's say they were igneous rocks. Oh, one quick thing actually that's really important, and I should have stated this. This is very, very important. To form a metamorphic rock from an igneous rock or a sedimentary rock, or even another metamorphic rock, you never completely melt the rock. All right, that's really important. If you melt the rock, you go back to magma, right? You've turned it back into magma, and then the thing could become, then eventually, if it's going to become a rock, that little bit of magma or whatever it is, if it's going to become an igneous rock, right? When it reforms. Okay, because a metamorphic rock, you're partially changing it. You're not completely melting it. The moment it completely melts, it's turned into magma. All right, that's really important. All right, so you have these rocks that are, let's say some igneous rocks that exist deep inside the Earth. and some heat approaches. There's some heat source. This is from deep inside the earth, and that will alter those igneous rocks. Okay, so if it happens over a huge expanse, you could have there's pictures, for example, in the textbook that show huge parts of Pennsylvania, for example, where there's what they call regional metamorphism, and so this large region, and this is not just in Pennsylvania. There's other areas as well, where you have this these large amounts of metamorphic rock that are produced because of what's going on in that particular region. All right, and we haven't started talking about plate tectonics yet, but that's really where we're heading. All right, so that'll be after chapter 20. All right, so I'm just going to try to finish up chapter 20 here. So we have metamorphic rock. Again, there's two general types. What are called foliated. So these are layered, not layered in the sense of we talked about layered when we talked about sedimentary rocks, because you have layer upon layer that's laid down. These layers are usually they won't be flat. They'll be like there'll be like a little S shape or something. It doesn't have to be an S shape, but it won't be just a flat shape. Okay, and you'll see when we look at pictures of it. And then of course there's non-foliated metamorphic rock. All right, so those are hard to identify, as we'll see here. All right, so here's some metamorphic rock. So slate, this first one A here, this is slate. So this is nice, very, very easy to see. These layers, but it's not sedimentary rock, right? There's not like it doesn't have like fine grain or anything like that. Schist, this right here is schist. Kind of looks more like it's been put together, slapped together, glued together. But these are larger. These are very large particles inside of it. And then this is kind of what I always think of as foliated. This gneiss. You pronounce this gneiss. So when the folds are curved, I know I said S-shaped earlier, but when they have these curves in them, that's classic foliated metamorphic rock. All right, so one metamorphic rock that is non-foliated, or a very, very famous one, of course, is marble. There's a nice picture of marble, and then the other one is quartzite. Quartzite. All right, so those are two good examples. Marble is an example of so it's actually metamorphized limestone. So remember, limestone comes from lots and lots of sea creatures that use calcium carbonate and that's where the limestone forms. And then when it gets metamorphosized, that's what we call marble. And some people have marble countertops, for example. That would be a good example of metamorphic rock. That would be like in your house. Of course, humans have been making statues of marble. The famous Michelangelo carving David. That's made out of marble. All right. So we just did that. All right. And so the last thing. Let's see how much time I have. Of course, I don't have much time at all. The last thing is this thing called the rock cycle. So I'll just introduce it